In Chapter 6, we're going to consider the idea of a sampling distribution. So far in earlier chapters, when we were considering distributions, we knew the mean and the standard deviation for whatever random variable we were considering. Most of the time, though, we don't. We have to estimate them. So for example, if you're looking at the population parameter of mean, or mu, you can estimate that with the sample mean, x bar. Population variance, sigma squared, can be estimated with the sample variance, s squared. So you take a sample, find the variance of that sample. That one number is an estimate for sigma squared. Standard deviation, sigma for the population, estimated by sample standard deviation. And population proportion, p, can be estimated by the proportion in the sample that has the characteristic that you're interested in. So these sample statistics, these guys here, they are actually random variables because different random samples give different values of these statistics. And so then those random variables have distributions. That's what a sampling distribution is. So let's examine this in a little bit closer detail. So we sample 5 households. We find that they have a mean income of, say $60,000. So that's the mean of the 5 households. We sample 5 more households. We find the mean income in that sample and say it's $65,000. And then we keep doing this. And then we look at the distribution of those sample means. That's a sampling distribution. It's the probability distribution of our sample statistic, whatever sample statistic that is that we're considering. So let's look at a simulation here. So here I've got a parent distribution, happens to be a normal distribution. And I'm going to take samples here of size 5 and then figure the mean of the samples. So there's my 5 values. And then here's the mean of those 5 values. Now notice this distribution goes from 0 up to about 32. So we had 5 values between 0 and 32, and then the mean of that. And then we take another sample of size 5, and that has a slightly different mean. And then we do it again. And we keep repeating this process. So if I do 5 samples at a time, so I did 5 samples of size 5, that added 5 more means down here. Then I do it again, keep on taking samples of size 5, and then you start to see a distribution forming. Well, let's speed it up here. Let's do 10,000 samples of size 5. And then you see, oh, look, this is looking like this is kind of a bell-shaped distribution. Let's look at 100,000 samples. And then another 100,000. Now it's not changing very much, but we can see that this distribution of sample means, that looks like it's a fairly bell-shaped distribution. And we notice that the spread in this distribution is smaller than the spread in the parent distribution. So this distribution, that is a sampling distribution. Now notice that the center of this distribution is the same as the center of the parent distribution. So up here, the mean is 16. Down here, mean is 15.99, almost identical for several 100,000 samples. So what happens here is if we did not know the mean of this parent distribution, we could find out information about the mean of the parent distribution by looking at the distribution of samples of a given size. And we can change this size if we want to. We'll examine that in a little bit more detail later.